Okay, all right. So in the interest of time, let me just jump into the outline of this talk. So it has been discussed several times in different forum, presentation, and also the booth demos. So for this particular talk at OCP, we want to focus on the technical aspect, especially the system and optical module integration and evaluation. And so first thing, I will briefly touch upon the optical interconnect scaling challenging and opportunities, and also where the LPO stands compared to other options. And next, we are going to talk about the evaluation matrix for LPO, which is the matrix that we are using as a guiding principle and meta to approach the technology investigation. And next, we are going to talk about the system calibration and as well as the 51T switch, data evaluation, etc. And we will summarize the talk with a call for actions. All right. So as we all know, from the past 1.5 days or so, we are all convinced that the optical interconnect is very important that we should focus on, and especially for the future AI cluster advancement. So, and we all know that this is not without challenge, right? So on the right-hand side, the table summarizes our thoughts back a few months at the beginning of the year, comparing different solutions, naming the retimed pluggables, the LPO in the center, and also the CPO. So, and the color here represents our thoughts at the time that we represented to the industry. So I won't go into the detail here, but if you are interested, I'm happy to take it offline with you. For the purpose of this talk, though, I want to draw your attention to the LPO. And based on the progress made in the industry, I think there are a lot of convincing results that we're seeing that the link performance is making significant progress. But as you can see, in the center column, there's a flashing red, which is the link accountability for LPO. And that is the particular reason for an end customer like us to adopt it at a wider scale. So this will be the focus for this particular talk. All right, let's jump in. So here shows a very simplified view on the physical implementation for different types of optic solution. So on the top, this represents the retimed pluggable. And we are all very familiar with this pluggable type. And this has been the driving force for our data center and across the many different hyperscaler peers as well. So in this case, the definition, there's a well-defined test point that allows the interoperability and also allows a multi-vendor open ecosystem. And with this implementation, the innovation can be allowed within the accountability area, which is the gray box for each cases. So this is very powerful because as long as the test point requirements are still being met, the technology can be innovated in an independent way so that we can take advantage and accelerate the whole ecosystem. On the other end of the spectrum at the bottom is the CPO. So the industry, including Meta, has been invested in this technology. And of course, it does have its own challenges in a different way. But in terms of the link accountability, the CPO can be made interoperable to the retimed optics. So in the center, there are two scenarios for the LPOs. As we are almost convinced by the demonstration and results showing by the industry partner, the end-to-end with a closed control of the entire system, the LPO could work. And as long as you have this end-to-end control and everything is owned by one single, let's say like vendor or vendor sets, this could work, right? But in order for the hyperscaler like us to deploy the LPO solution in a meaningful way, we really want to see the interoperable open ecosystem. So again, this is the focus, and I will pass on the mic to Qing to talk about more technical details.
Thank you, Janet. Hi, everyone. My name is Qing Wang. I'm an optical engineer at Meta. So the big picture of the LPO is with the recent development of the SerDes capability, especially at the ASIC. So there is a trend to switch from the analog SerDes to digital SerDes that make the LPO possible. And it's a complicated problem because traditionally, the DSP in the optics kind of separate the electrical domain from the optical domain. So it's a divide and conquer. Each section was taken care of separately. With LPO, the host SerDes needs to take care of the whole link. It's a complicated problem, but doesn't mean there's no solution. To simplify and accelerate the development of LPO ecosystem, we are making the proposal of this evaluation matrix of the LPO. So first of all, we limited the problem to 100G per lane for now. It means 2 by 400G, 8 by 100G, and 1 by 800G mode only. We're not considering, we are deprioritizing the backward compatibility with the legacy optics, like 50G per lane or 25G per lane. Yes, we need to have interoperation. You guys just saw there is a problem with this interoperation just now. However, what does interoperation mean in this case? So for LPO, we require interoperability between different LPO vendors and also between LPO and the retimed module to form a healthy ecosystem. And on the host SerDes tuning, we want to avoid to the maximum extent the handshaking between the optics and the switch. Means the switch calibration should be independent of the optics, and the optics calibration should be independent of the switch. There are some nuance in this kind of criteria. For example, there could be per port, per switch MPN, per SerDes calibrations. And also, there could be some common setting provided by switch on per module basis, sorry, on per switch MPN and per port basis, like the ARCS equalization we had before. On the end-to-end, a prefix BR target, we're preliminary setting 3E-6 as our target. And then for the fiber optic link budget, this is about FR4 light. So we define our use case to be 500 meters and also insertion loss less than 2.5 dB. So it has been widely discussed about the test points, TP1 to TP4. For TP2 and TP3, our thought is to use the Meta 2x400 FR4 light spec. It's similar as the IEEE FR4 spec with some relaxation. On the TP1A, TP1, TP1A, TP4, TP4A spec, it's still TBD. We had some thought, we have some draft, and we're going to work on that and try to polish that more. So it's right now TBD. On the 200 per lane, we would like to have some feasibility there because we don't want to have this investment and effort into 1 by 100 per lane like wasted, right? So diagnostics, I think as some speakers said before, it's very important to take the serviceability and the diagnostics at the heart, right? When we operate like millions of optics in the data centers, especially for the AI ML use case, where lossless network is assumed. Now, what's the problem? So in terms of the impairments, at high level, there are 3 kinds of impairments: jitter, ISI, and noise or distortions. So let's look at them one by one. For jitter, module is not a source of jitter and should be transparent to host jitter. For ISI, previously, the optics DSP in the module will take care of the different spans. However, right now, without the retimer or DSP in the module, the host SerDes needs to take care of the whole link, which is 2 C2M links, and also the module O2E and the E2O links. this requires more precise host TXFR adjustment. And then noise and distortions, the host and module noise sources are additive. And there is no regeneration during the E2O, O2E process. And there is also limited tuning on PAM4I linearity. So like we talked about, ideally, as we proposed, the system calibration should be system focused. That means the host setting should be independent of the LPO module. In this talk, we are proposing to determine the host setting based on the TP1 matrix. And in a moment, we'll talk about what that means. And this is mainly addressing the ISI on the TX channel at the host side only. On the module calibration, module calibration and control should be adaptive. So on the RX side, it's pretty familiar to everyone that AGC should be running. But on the TX side, we think the AGC is also required, which is very different from the retimed module. And there is a certain margin that we need to reserve to compensate for different like color cases, like changing over temperature or change over life. So right now, we're going to showcase a methodology to calibrate the system and the LPO so that it can form a healthy link. So in this case, we start to set the TXFR with some initial setting that should be able to get us to measure the I and the TCQ and the DCA. So then we send this signal to a DCA, which is treated as a RX reference RX. So the RX FFE type values will be automatically adjusted in the DCA by repeatable and consistent LMS method. After we got that RX FFE type values, we just do a convolution between the RX FFE types and the FIR init to get the final types. And if needed, this TXFR final can be also scaled to adjust the TP1A swing. So all the type values, including the main type values, mean type value will be adjusted similarly. Now, following this methodology, we calibrate the TP1A for all the 64 800G ports of this 51.2T switch. For each port, it's 800G or 80 by 100G per lane. As you can see, the result is very encouraging. The TECQ through all ports is less than 1.1 dB, and the VPP through all ports is between 230 millivolts and 500 millivolts. I think in the latest ORF draft, if I remember correctly, the maximum limit of the swing is actually 500 millivolts. The low limit is TBD. And on the right, you can see the TXFR pre-type weight and also the post-type weight. You kind of can get an idea of the host insertion loss indirectly. Now, on the LPO side, how do we do the LPO calibration? Basically, the point here is same picking should be applied to modules in all ports. And the same swing gain should be applied to modules in all ports as well. So to support this, the host swing should be consistent across all ports by scaling all the TXFRs. So for example, this means for the shorter trace, we would scale the taps down to the certain level so that the TX swing is uniform across all the ports. Now with the AGC of the LPO driver, it will improve the tolerance to the swing variations. RX TIA tuning is relatively straightforward because it's already implemented in the retimed module. Now, this is the TP2 result following the TP1A calibration we just talked about. As you can see, two groups of data were presented here, representing two designs. So, as you can see, the TP1A swing is across through all the ports, which guaranteed the ER, uniform ER through all the ports. And the RLM is pretty good as well. So the TDECQ can marginally meet retimed TP2 spec, and the ER strongly depends on the driver and the host swing, which is understandable. So with some optimization, with some further optimization, as you may imagine, like the TDECQ can meet the spec. At least it's promising. So we don't have too much concern about the end-to-end BER. I think this has been shown in various talks. I think the problem is if we can achieve no BER in all the cases through the quarter cases, not just the average or the median cases, but also the 3 sigma scenarios, right? So here we showed different interoperation scenarios between the retimed module and LPO and LPO and LPO, and also the DR and FR use cases. As you can see, in terms of the sensitivity margin, we have about 3 to 5 dB sensitivity margin. But we also noticed in our development, there is some dependence on the BR floor because of the crosstalk. So this is something we need to take a closer look. Now, this shows the correlation between TDECQ and the TECQ for the LPO. And also, as you can see, it's pretty correlated, which is understandable as well. And we didn't show here, but TECQ and the retimed TP2 are uncorrelated, which is also understandable. On the right side, it shows that there is some trade-off between ER and the TDECQ. So this gives us some leverage on how to optimize the module design so that you can meet these two specs at the same time. Finally, call to action. So LPO, as we just mentioned, because of the lack of the retimer or the DSP in the module, the electrical domain and the optical domain were tightly coupled. So the switch host and the module vendors should align to the calibration methodology that optimizes interface accountability, manufacturability, and integration. And here, we proposed an approach based on TP1A to do the host calibration and adaptive module settings. Thank you.
All right. Thank you very much. Just a clarification question. So some of your charts were showing data for design 1 and design 2. Are those different switch designs or transceiver designs?
Good question. That's different module designs.
Module design?
Yes.
Okay.
Yeah.
And were they based on different technologies, or what were?
Similar technologies, but optimization of the subcomponents.
I see. I see.
Yeah.
All right. We only have time for 2 quick questions, and then we have to move on. So please go ahead.
Oh, thank you for the excellent talk. So I have one quick question. So does Meta will the application of this LPO technology mainly for a small percentage of the network, certain niche applications like some bookended lower loss links, or Meta is looking to deploy this to a much larger scale as a backbone of the network? Thank you.
Thank you. That's a very good question. So there is a balance between the larger scale deployment and the limited use cases. And it's not surprising to say for each one there is a certain advantage and disadvantages. I think what we're thinking right now is to start to penetrate into this space through some MVP definition, which means we are willing to relax some of the requirements, just that we talk about, to accelerate and speed up the ecosystem development.
All right, one more question.
Can you tell us something about? Ollie, I'm second. About the T.Q data, did you see any correlation between the T.Q or the T.Q-like data and the overall bit error rate? And was there correlation or anti-correlation, or were there situations where the correlations changed? If you could comment on that, that would be helpful.
Thank you. That's a very good question. So I think traditionally there is a lot of discussion about correlation between TDCQ and the BER, even for the retimed module. And we all know it's probably not the best correlation through all the corner cases. But assume every vendor or every design is done in a sensible way, we still think the TDCQ is a useful metric, right? It doesn't mean it's the only metric, but it's still useful metric for reference.
Did you, for example, find that usually the best T.Q corresponded to the best bit error rate, or what?
Thanks. I think, like I said, it's probably not correlated in all the cases, but trend-wise, they can still be correlated.
Thank you.
Yeah, no problem.
Let us thank the speakers one more time.